Okay, welcome back. Okay, this is part 2 of going through the substitution rule. And so I'm going to go through, I think, 2 more examples during this section and just increase the complexity a little bit. What you'll find, though, is that it's not really that much more complex. And so just kind of, if you look at the textbook, they just try to increase it a little bit, the difficulty a little bit at a time. But if you just kind of follow their examples a bit and work through it, actually, it works out pretty well. So I'm going to start with the integration of, let's say, I'm going to get a little bit vague. Let's say a plus b, and we'll say that that is x to the 3 over square root of 4ax plus bx to the 4th dx. Okay, so in the last video I was telling you, evaluate what's the part of the problem that's trapped. So if you look at anything in a square root, that's definitely trapped in there. So it's a good target to start off with on what is going to be your value of u. And this one is really teed up to work out pretty well because you know you're going to have to take whatever you assign as u, and you're going to have to take the derivative of that. And then you're going to have to hopefully cancel out any components of x thereafter. So what you're going to see is the derivative of that tees up really well to cancel that one out there. So without talking too much more, I'm going to just go through it. So 4ax plus bx to the 4th, the derivative of that is just going to be 4a plus 4bx to the 3rd, that's a b. Okay, and then this has a dx component, and don't forget that because that's the key to the next step. So then we're going to solve for what is going to replace my dx here. So that's just going to take this section here, move it to the other side. So it's going to be du over top of, I'm going to take the 4 out too. You can see that that was nicely teed up for us there. 4a plus bx to the 3rd. So if you notice that and that, you can already see the future a little bit. Those things are going to cancel each other out. So let's do the substitution to go from x domain to u domain. And so I'll just tell you what, we'll keep a plus bx to the 3 there, and we have square root of u. Now that goes directly in for that one right there. And now we're going to substitute that dx for what we found here. So du 4a plus bx to the 3rd. Okay, so you can see next step is we're going to cancel those 2 out. And we're going to carry the 4 to the front. This is a multiplication, not an addition. So the 1/4, and we're left with du over square root of u. Okay, so piece of cake now, right? Because we know 1/4, this actually equals u to the negative 1/2 du. So we can solve that just by taking, let's see, this, and then adding a half or 1 to it, that exponent there. So we'll go 1/4 and this is always something I always pause and take a look at. And so this is actually a 2. So you take that, flip it upside down. Actually, we'd be making that plus 1/2 by adding 1 to it, and then take the inverse of it and multiplying it out in front. So that's our integration right there. And then it's plus c, of course. And now we're responsible for substituting back in what we originally had to sign what the value of u was. So we're going to be left with 2 over 4 for that first part. And then I'm going to have to put in 4ax plus bx to the 4th there for that guy. And that's to the 1/2. And that's plus c. So that is our answer for that integration. So it's really just a simple substitution, no big deal. And because the problem was teed up for us, it was just really easy. Sometimes you might want to look at separating because you have a plus sign in the numerator. You can put the denominator over that and that component. In this case, didn't make sense to do that. We kept it simple. So next problem I want to do is let's start introducing a simple trig function. And so let's take cosine, and we'll just say 2 over x. And then we'll put that over x squared dx. Okay, so what is trapped? The 2 over x is trapped. So let's start there. U equals 2 over x, and that equals 2x to the minus 1. So du would then equal, so we're just, actually this is a derivative, so it's going to be 2 times negative 1, say here, and then x to the negative 2 dx. Okay, so let's solve for dx to do a straight substitution for that value right there, and then we hope for the best that that cancels, and it looks like it's going to. So we can move this to the other side, and instead of being a negative 2, it's a positive 2. And then this guy goes to the other side, so we have a negative 1/2, and that's going to be x squared du. Okay, so let's start substituting in. And we'll go the integration of cosine, and this becomes u over x squared, straight bring that down, and then we'll substitute this guy. And we'll just put in negative 1/2 x squared du. And if you look, the problem was defined nicely because that guy and that guy are going to cancel out in the next step. So we have cosine u, we got rid of that, we got rid of that. We're going to move this to the front, so negative 1/2 du. So that looks pretty good. So next step is negative 1/2, and it's going to be a positive sign, sine u plus c. Substitute our x in for u, negative 1/2 sine, and that is a 2 over x there, plus c. Simple as that. That is your answer. Okay, so we'll do another part after this, part 3, just to ramp it up a little bit and just make sure you can handle any type of problem that's thrown at you. So subscribe to the channel, you'll see, take a look at the channel, you'll see part 3 in there. So anyway, good luck, I hope this helps.